Hello everyone, and welcome to another episode of Cabinet of Curiosities on Our Own Devices. I'm Jean Messier, and I'm here at 17 Wing having a look at some bombs, specifically 11.5-pound practice bombs. Now, these would have been used by various Commonwealth countries during the Second World War to train bombardiers and ground attack pilots. And they would have seen their greatest use as part of something called the British Commonwealth Air Training Plan, or BCATP. And this was an absolutely massive undertaking in which Allied aircrew, including pilots, bombardiers, navigators, wireless operators, air gunners, and ground crew, would be trained in Commonwealth nations far away from the front lines, places like Australia, New Zealand, South Africa, Bermuda, and Canada. And in Canada, the BCATP was absolutely massive. At its height, it comprised 8,300 buildings, employed 100,000 personnel, and by the end of the war had trained 131,500 aircrew, more than any other nation. And this was by far Canada's single greatest contribution to the war effort and earned the nation the nickname the Aerodrome of Democracy. So the British Commonwealth used a wide variety of bombs for training purposes, including inert versions of regular service ordnance and 5 different sizes of purpose-built practice bombs, ranging from 8 pounds all the way up to 25 pounds. And the smallest of these, the 8-pound practice bomb Mark I, was rather interesting. It had a body composed almost entirely of asbestos cement, with a minimum of metal parts, basically just a small metal suspension band for hanging it from a bomb rack. And inside this cement casing was a small glass vial filled with titanium tetrachloride, which is a chemical that produces a dense white smoke on contact with air. And this was the standard smoke composition for all of these purpose-built practice bombs because it didn't have the same fire and burn risk as white phosphorus, which was used to produce smoke in combat. Now, these bombs were intended for practice against runways and other hard targets, and so they were designed to shatter on impact. And this would, of course, break open the vial, release the smoke compound, and produce a puff of smoke to indicate that the target had been hit. And the idea behind using this frangible cement was that it produced debris that was not hazardous to aircraft tires if not all of it was cleaned up. Now, the next size up was the 8.5-pound practice bomb, and this was of more conventional design, although it had a bakelite plastic body filled with lead antimony balls to give it the proper weight. And there were 3 different types, Mark I, Mark II, and Mark III. Mark I had the regular smoke filling. Mark II was identical, except it had a fitting in the nose for an extension rod. So this is a fitting on a lot of bombs to make them explode at ground level rather than burying themselves in the ground. Then the Mark III was for bombing practice at night and would have contained flash composition or flash powder. And this was a mixture of black powder and magnesium shavings that on impact would produce a bright flash that could easily be seen from the air at night, indicating a hit on the target. Moving up, we have the 10-pound practice bomb, and this had a cast iron head and a sheet metal tail unit, and this also came in 3 different varieties, Mark I, Mark II, and Mark III. The Mark I contained smoke composition for use during the day. The Mark II had an experimental plastic tail unit, but this was found to be unsatisfactory and quickly scrapped, and the Mark III contained flash composition for bombing at night. Then you get up to the 11.5-pound practice bomb, just like these here, and here there are only 2 varieties, the Mark I, which was the standard, and the Mark II, which was an experimental bakelite model produced in the United States, but this too was considered unsatisfactory and scrapped. And unlike the smaller sizes, there was only one version used for both day and night. You didn't have 2 different versions for the different compositions, you just filled the same bomb with either smoke or flash composition. And then finally, we get up to the largest size, the 25-pound practice bomb, and this came in actually 5 varieties. So the Mark I was filled with smoke for daylight practice. The Mark II was again a plastic experimental version that was quickly scrapped. The Mark III was filled with flash composition for use at night. The Mark IV was an upgraded version of the Mark I. It had small modifications such as thicker arming pins and superseded the Mark I. And then finally, the Mark V was identical to the Mark IV, except it contained flash composition instead of smoke composition. All clear? Anyway, all of these bombs, except for the 8-pound, use some sort of bursting charge in order to scatter the smoke or flash material. And let's have a closer look at the 11-pound bomb and see exactly how that mechanism worked. So here we have our 11.5-pound practice bomb, and this consists of two main sections, the head and the tail unit. And these thread together as so. If we have a look at the tail unit, we'll see two holes. The smaller hole, which would be normally filled with a threaded plug, is the filler hole. And this would be used to fill this conical tail section here with either the smoke composition, titanium tetrachloride, or the flash powder composition. While this well in the middle here is for the bursting charge. Now this would have been a standard component called the number 28 detonator burster, and this consisted of a mercury fulminate percussion cap and 7 pellets of CE or tetryl explosive. And normally this was used as a booster charge to set off larger explosive charges. In this case, it supplied just enough explosive energy to burst this tail unit and scatter the smoke or flash composition. So this part of the bomb was expendable and would be destroyed with each practice bombing run. Now, if we have a look at the head, this is a lot more durable. This is made from cast iron, and it actually has an annular space in it that's filled with molten lead in order to make it a lot heavier. If we look in the back here, we'll see the end of the firing pin. And this is attached to a plunger in the nose, which would be pushed back on impact to drive the firing pin into the percussion cap on the number 28 detonator burster. You can see that this is held in place by two different safety pins. This one down here with the little tag is a ground arming pin. So this would remain in the bomb throughout ground handling and be removed by the ground crew just before the aircraft took off. You see it's got a little tag on it with instructions, and this reads, "If bomb is not dropped, replace split pin, removing from carrier and secure safety pin with suitable wire." And on the other side, wire surrounding bomb to be removed and split pin withdrawn after bomb has been placed on carrier. The second pin on the top here, however, would be held in place by the bomb rack itself and would not be released until the bomb was actually dropped, and the spring would push it free, finally releasing the firing pin mechanism and allowing it to detonate the bursting charge on impact. So let's actually pull these pins free and have a look at what this firing pin looks like. And there we go. Now, normally in a mechanism like this, you would have some sort of retaining spring to keep the firing pin in place and prevent it from prematurely hitting the percussion cap. In this case, this was done using a shear wire, which would fit through this little hole in the back of the firing pin and in the bushing at the rear here. And that would hold the pin in place during handling, and then on impact, it would require a certain amount of force to actually shear that wire and allow the firing pin to move rearward and hit the percussion cap. So really quite a simple and effective mechanism. And one last thing to note here is that these bombs have a single suspension lug at the top here, and in a little bit we'll look at exactly how these would have been fit to the bomb rack. So interestingly enough, Canada actually had its own version of the 11.5-pound practice bomb that worked a little bit differently from its British counterpart. And the easiest way to tell these apart is that the British bombs have a very steeply conical tail section with a short stem holding the tail fins, whereas on the Canadian bombs, the tail unit tapers straight from the head all the way to the rear of the tail. And if we take this apart, we'll see a couple of other differences. For example, the threading on this is reversed. The female thread is on the tail, whereas the male thread is on the head. If we look inside the tail unit, we'll see that there is no compartment for smoke or flash composition. There's no filling hole. There's no well for a bursting charge. It's just a hollow tube all the way to the rear. And if we look inside the head, at the base here, we'll see two kidney-shaped holes for filling the head with lead to adjust its weight. But otherwise, there's only one much larger hole here. And this is because this type of bomb was designed to take a self-contained cartridge. And so that cartridge would be slotted into this well. The tail would be attached as so. And then when this hit the ground, as before, the plunger would push the firing pin back into the percussion cap on the cartridge. But instead of blowing open this whole tail unit to release the smoke or the flash, the cartridge would go off and the smoke and the flash would be vented up through the hole in the tail. And so barring impact with some hard object or at a strange angle that would just completely mangle the sheet metal tail unit, these were a lot more reusable and affordable than the older British versions. And otherwise, this is the same as the old British version. We have our suspension lug here, and we have our two safety pins. This one has the split pin, which would be pulled out by the ground crew, but it is missing its aerial arming pin. So among the Commonwealth nations, Canada was fairly unique in using a cartridge-based practice bomb, but another of the Allied nations, the United States, actually made extensive use of this type of bomb, and for the sake of completeness, I thought I might show you an example. This is an AN, or Army-Navy Mark 43 practice bomb, and there are actually three different versions of this basic design. There was the Mark V, which was cast from a zinc alloy. There was the Mark 23, which was made of cast iron, and finally the Mark 43, which was cast from a lead antimony alloy. So as you can see, this is a really quite simple device. This is just a solid block of cast lead with solid fins at the back. There originally would have been a thin sheet metal band wrapped around the fins, and this would be to control the bomb in roll. If we look at the nose, we'll see the well where the cartridges were inserted, and this would have used what were known as Mark IV pyrotechnic cartridges. These are basically 10-gauge shotgun shells filled not with lead shot, but rather a phosphorus-based pyrotechnic composition. And there were two versions of those. There was the Mod 0 and the Mod 3. And the only difference between them was that the Mod 0 had a paper cartridge, whereas the Mod 3 had an aluminum cartridge. Now you would slot that into this well. You would put a firing pin mechanism, which you can see is loose inside here, on top, and secure that with a shear wire and a safety pin. And there were two different types of these fuse assemblies. One was held in place securely, and when the bomb hit the ground, inertia would cause the cartridge to slide forward and slam itself against the firing pin. The other version was built of two lead pieces that would actually shear on impact, driving a firing pin into the cartridge, but otherwise they work pretty much the same way. And these are designed to be used with something called a Mark 47 bomb rack, and this was a pod that could be mounted to the hard points of an aircraft that would hold 8 of these bombs in little compartments, each of which could be electrically opened from the cockpit. And each also had a powerful spring so that when the bomb doors were open, the spring would just push the bomb out free of the aircraft. Now, hopefully if I can get my hands on other US practice bombs, I'll do a video on those, but for the moment, I thought this would just be neat to show what sorts of systems were in use by other Allied powers. And now let's have a look at how these bombs would actually be secured to an aircraft. This is the bomb rack off a Bristol Bolingbroke, which is the Canadian manufactured version of the Bristol Blenheim light bomber. Now, the Blenheim was the UK's first modern all-metal monoplane bomber, but by the outbreak of the Second World War, it found itself hopelessly outclassed by German fighters, and those that were sent into combat suffered horrific losses. However, quite a number were built in Canada by Fairchild Limited and used in the training role, mainly for training bombardiers and air gunners, and in this role they were quite successful. Now you can see that this rack has been fitted with two different types of bombs, a British and a Canadian version of the 11.5-pound training bomb, and these were suspended by a single suspension shackle that fit into this latch mechanism here, and this latch would have been activated by a solenoid in the bomb rack itself, and here we have the actual electrical wires leading up to the cockpit. So when the bombardier pressed the bomb release button, it would send an electrical current to the solenoid, open up this claw, and release the bomb. Now, since this only has a single point of suspension, you need at least one other point of contact to stop the bomb from rocking back and forth. So we have a cradle in the back here and a cradle in the front, and this doubles as a retention mechanism for that secondary arming pin that we talked about. So when the ground crew would load the bombs, they would place them in the cradles, they would lock this latch around the suspension lug, then they would pull out the ground arming pin and remove the wire, and that would leave the secondary arming pin in place on the cradle here, and then when the bomb was released, a pin would fall away and arm the bomb. And finally, just a note on the proper markings for these bombs. Now, a lot of the bombs that you'll see on the open market have probably been painted and repainted many times over their lifetimes and probably don't have the proper markings. So the official paint scheme for these would be white all over with a pair of green bands on the tail to indicate a training munition. And all the models that had a bursting charge, basically all of them except for that 8-pound cement bomb, also had a red band around the nose to indicate the presence of explosives. Now, certain versions of these bombs would have been used well into the 1970s and 80s, and those typically would be painted a pale blue to conform to NATO standards for marking inert munitions. And during the Second World War, standard munitions, regular bombs that were rendered inert, say by filling them with cement for training purposes, would have been painted black. Anyway, that's all I have for you today. Thank you so much for watching, and a huge shout out to 17 Wing and Nick Reeder. You might remember him from my video on the Link Trainer for lending me some of these bombs to look at. I'll see you next time on another episode of Cabinet of Curiosities, where I'll look at yet more fascinating devices just like these. Until then, I'm Jules Messier from Our Own Devices. Have a great day.